Good morning, ladies and gentlemen. Welcome back to Katsina State Senior Secondary School's online connect, powered by exponential computers. Physics lesson for SS3 students. Week 6. I, the presenter, Ismail Baraya. So, for the week 6 class or contents or lesson, here are the topics or some content that we are to talk about. That is the state Coulomb's laws, also to calculate electric force between point charges, but those charges are at rest, and we are to calculate the electric field intensity due to an isolated point charges, and also we are to define electric potential, and lastly we are to calculate the electric potential due to isolated point charge. So let's go and see. So for the first content, that is the Coulomb's law. So normally Coulomb's law is talking about the relationship between those two charges, the force that is present in those two charges, that is the Q1 and the Q2. So it's talking about the Coulomb's law normally is talking about the relationship between the electrostatic force present in between those two charges, that is the Q1 and the Q2, between them. That is the force is talking about the electrostatic force. So let's state the law and see. The law of Coulomb's law states that an electrostatic force is present between two charges, which is directly proportional to the product of magnitude of charges, and that is the Q1 and the Q2, and inversely proportional to the square of the distance between them, between those two charges, that is the M1, or that is the Q1 and the Q2. And when we say Q, we are talking about those two charges, the Q1 and the Q2, and the R, that is the distance between them. So if you look at it here, like this diagram is trying to show us the Coulomb's law, is trying to explain the Coulomb's law, and it said that the Q1 is here on the left hand side, and also the Q2, that is the charge 2 on the right hand side, and also the distance between them, that is where the R come from. So but the R, it is in square, that is why it is in the square between them, between those two charges, that is why they are in, that is why it is in square, that is why they are in square. So Fe, if you look at it, this formula Fe is equal to the E normally is the electric force is equal to K Q1 Q2 all over R square. So normally this is the formula for Coulomb's law. So but let's see if we can expand the formula for Coulomb's law, and we are trying to find the constant, the K, where this K come from. But let's see here. If F is the force present between two charges of magnitude Q1 and Q2, and R is the distance between them, then we can write it down as F is equal to K Q1 multiplication O times Q2 divided by D. That is when we say D square, that is the distance between them. So but this K normally is a constant of proportionality governed by the Coulomb's law. So this formula, and when we say something it is in constant, when we say Coulomb's constant, we mean that this constant value of this K is not changing. So wherever you see it, normally this K in physics is talking about the Coulomb's law constant. It has a value of where this K is equal to 1 over 4 phi epsilon naught is equal to 9 times 10 to the power of 9 Newton meter square per Coulomb square. So this value normally is a constant value for Coulomb's law, and this is for K, that is the alphabet K. But when we say something is constant, we mean that anything can be given except this value. Why? Because it is constant, it cannot change. But the Q1, or the value of Q1 can be changed, can be given, the value of Q2 can be given, and also the D or the R, that is the distance between them, they can also be given. But this K normally is constant value, which has a value of 9 times 10 to the power of 9, or This 9 times 10 to the power of 9 is also equal to 1 divided by 4 pi epsilon naught, so it's equal to k. So this value is for k. Wherever you see this value, whether you have a 1 point, whether you have 1 divided by 4 times 10, sorry, wherever you see this value of k is equal to 1 divided by 4 pi epsilon naught, it's talking about Coulomb's law. All this 1 value by 4 pi epsilon naught is equal to 9 standard 10 times 10 to the power of 9 Newton meter square for Coulomb. So this is constant value for Coulomb's law. So normally the law of electrostatic, that is the law of electrostatic here, it says that like charges repel, unlike charges attract. If you look at it down here on the left hand side down, you will see that q1 and q2, but if you look at it normally, you will see that they are all in positive, and when we say positive, we mean that like they are in plus sign plus plus sign, they will repel each other. Why? Because they are in they are in the same gender. There is no attraction between them. The positive charge and the positive charge, there is no attraction between them. But a negative charge and the positive charge, there is attraction between them. And also a positive charge and negative charge, there is attraction between them. But a negative charge and a negative charge, there is no attraction between them. They will repel each other. So this law says that like charges repel, unlike charges they will attract. So whenever you have a positive and a negative, they will attract each other. You will see we will have a positive, that is the plus sign, the q1 and the q2. You will see that they are in contact, they are facing each other. But if you look at the off one, the one they repel, you will see that they will refuse each other. All of them will have their own way. Why? Because they will repel each other. That is the law. So they will not attract each other. They are repelling. And when we say repelling, we are talking about like they will repulse each other. But if they are in different kind, when you are having a positive and negative charges, then there is attraction between them. You will see that they are piercing each other. They will attract, they will be in contact with each other. And here we have a Coulomb's law. So this formula is used for calculating Coulomb's law. So where it says F is equal to K Q1 Q2 all over R square, and also this is equal to, and if you look at it up here, up there we have a constant value of Coulomb's law. This K is equal to 1 all over 4 pi epsilon naught. If you look at it down here, it also like the same. We just remove the K. We just put K is equal to K is equal to Q1 Q2 all over R square is equal to Q1 Q2 all over 4 pi epsilon naught R square. We just remove the K because we say K is equal to this value of 1 divided by 4 pi epsilon naught. So we just put the value of this 4 pi epsilon naught. And also this value of 1 all over 4 pi epsilon naught is also equal to a value of 9 times 10 to the power of 9 Newton meter square per Coulomb. It also the same. If you also put this constant value of this K, it also the same. This formula also it means for Coulomb's law. It means for how to find a Coulomb's law. So this is about Coulomb's law. So let's see an example of finding of a Coulomb's law that says that this. Let's see this example one. A positive charge of 6 times 10 to the power of minus 6 C, and this C normally stands for Coulomb because it is in Coulomb, is 0.40 m, and this m is talking about the meter. The m is talking about the meter, and when we are talking about the meter, we are talking about the d or the r, that is the distance from the second positive charge of 4 times 10 to the power of minus 6 Coulomb, that is C. So we are to calculate electric force between those two charges, these two charges. So let's see if we can be able to calculate the charges between them. So normally, if we know our formula for calculating Coulomb's law, that is the one that we just finished explaining, that the one that says Fe, that is the electric force, it is equal to K Q1 Q2 all over R squared. That this formula is used for calculating the electric force between two charges. So you see, and the value of Q1 is given, the value of Q2 is given, and also the value of R they are given. So the only thing is that this k is a constant value. We don't have to give it. If you can remember in our question, even the value of k is not given. Why? Because it is a constant of proportionality. Because I told you it's not given, it's not changing. It will not change. A constant of proportionality is not changing. So if you know a value, we'll just put them into action and see that k is equal to 8.99 times 10 to the power of 9. So you see this is a constant value for k, for Coulomb's constant. Open bracket, the value of q1, that is the one we have put, that is 6 times 10 to the power of minus 6. Open bracket, put in the value of q2, that is 4 times 10 to the power of minus 6, that is the value of q2, divided by the r or the d, but it is in square, that is the 0.04, it in square. So let's just let's square the distance or the r and see what we are going to have. Okay, the down one here we have, when we just multiply this 6 point sorry when we just multiply this value of q, the charges, that is the 6 times 10 to the power of minus 6 multiplication, or times 4 times 10 to the power of minus 6, we will end up, or will be having a value of 2.4 times 10 to the power of minus 11. So this is the value that we have for the multiplication of those two charges, and also divided by the r or the d, that is the radius, that is the 0.4, but it's in square. Then the 0.4 square, we will end up with 1.6 times 10 to the power of 3. That is the value for the square root of the r, that's the radius. So, and the upward, if we just multiply the constant value of the Coulomb's law, that is the 8.99 10 to the power of 9 times 2.4 times 10 to the power of minus 11, will be having a value of 0.211576. That is the value that we will get. Then we will just divide it with the radius, but that the radius that we have in square, that is the 1.6 times 10 to the power of minus 11. Then if we just press our own calculator and press 0.21576 divided by 1.6 times 10 to the power of minus 3, then we'll be having a value of 134.85 n. And this n, if you can remember, electric force is used to measure in Newton. That is where this n comes from. So the electric force between those charges, it is this value that we have, that is the 134.85 Newton. So this is the value for finding the electric force between the q1 and the q2. So this is about the calculation of Coulomb's law. So let's go and see. So we are at the second context. The second context is talking about the electric field intensity. So normally the electric field intensity is talking about electric field, and when we are talking about electric field, we are talking about electrically charged particle, that is the positive charge particle and the negative charge particle. So normally the strength of the electric field is measured using a quantity called the electric field intensity. So you see that value of that electric field, so it's used to measure using the electric field intensity. So, and also the greater the electric field that we have, and also the greater the intensity of that field that we are going to have. So by definition, electric field intensity is defined as the force experienced per unit positive charge at a point placed in the electric field. So you see, it is a force that you will experience, or it will feel per unit positive, that is the charge, that, or let's say a positive charge, a positive charge at a foreign place in the electric field. So this is the definition or the explanation of electric field. Electric intensity is defined as a force experienced per unit positive charge at a point given or placed in the electric field, in that field. So and normally electric field have an equation, and the equation is for that charge, for that positive charge, which says that the this E is equal to this E normally stands for the electric field strength, and is equal to for the F small, let's say Fe. So this E normally it is in small. That is the like the electric. It is called the electric force. That is where it is come from. This Fe. This they are that's where they come from. Divided by the Q naught. That is the epsilon naught. So normally it is the test charge. But this formula, it can also turn into, for this formula can turn into for a point charge. So whenever we are talking about for a point charge, a very that point, for that point charge, then that equation will change. You will just put the formula for the column for the constant for proportionality of that k, of that Coulomb's law, of this k. It comes from Coulomb's law, the one we just explained, the constant of proportionality of that field. So normally the intensity is equal to E is equal to kc, that is the constant of Coulomb's law, Q divided by R. So and normally this Q is the electric charge producing the field. So this Q stands for the electric charge producing the field. So if you look at it down here, you see that the E is the electric field strength. It is also measured in NC, that is the Newton per coulomb. So also it is also a vector quantity, is not it is a vector field, and it is not a scalar field. It is not a type of the scalar field. It is a vector. It is a vector field. It is a type of the vector field. So the Q naught, that is the Q, like a 0 here, that is Q naught. This is a positive test charge. That is the test charge of that charge. That is measured also in coulomb, because normally charge is used to measure in coulomb. That is C. So also the Q only, that is the charge, is the charge producing the field. So it is the one that is producing that field or that force. So it is this Q only. This Q is the one that is producing that field. And also, since it is Q, also it is charge, and also it is measured in coulomb. That is C. So R, normally R is the distance between the charges, between those two charges. And also when we are talking about the distance, we are talking about the meter. That is measured in the M. So then the Fe, that is the electric force. And when we are talking about force, normally we are talking about N. And when we are talking about M, we are talking about Newton. So normally electric force is used to measure in Newton. So this Kc, the one that we just finished explanation, that is the Coulomb's constant. That is the key, because which has a constant value of 8.99 times to the power of 9 Newton meter square per coulomb. And also you can do the approximation of this value of this constant value for the proportionality. You can just make it as 9 times 10 to the power of 9 only Newton meter square per coulomb, because it is an approximation. The more you just approximate 9 to turn into to turn that 8 into 9, it can be, you can do the approximation of that, or you can leave it like that. So this is about the formula, and also the definition of the electric field intensity, which says electric intensity is defined as the force experienced per unit positive charge at a point placed in the electric field. So this is about the electric field intensity, and about its formula. That is the electric field equation for a point charge. So normally this formula is used for a point charge. So here is one of the example, and this example, it says that charges, that, and when we say charges, it is not only one. So charges each of plus or positive 3 micro coulomb are placed at 3 corners of a square whose diagonal is 6 centimeter long. So that is the R, the distance in 6 centimeter. Find the electric field intensity at the point of intersection of diagonals. So normally if we know our formula for calculating electric field intensity, which says that the formula is here, which says E is equal to Q divided by 4 pi epsilon naught R square. So this is the formula for calculating the electric field intensity. So and let's see the values. What are we given? We have our Q. Our Q is given that is a positive 3, but it is in micro coulomb. That is 3 times 10 to the power of minus 9, because it is micro coulomb. So and what again we are given? But we are given the R. The R is given to us. The R in centimeter. That is 6 centimeter long. So normally when it is in centimeter, we have to convert it into meter. So let's see if we can solve this problem here. So if we start putting our value. So normally before I told you that K, the constant of proportionality for the Coulomb's law, it have a value of 1 divided by 4 pi epsilon naught r square. So with this, that constant of proportionality, it has a constant value of 9 times 10 to the power of 9 Newton meter square per Coulomb. So if you look at it on our value here that we start substituting, you will see that we just put our constant of the value here, and and what again, the Q, the Q is given here. So the Q we have 3 times 10 to the power of minus 9, because it is positive 3 micro coulomb. That is C, because of that micro, that is why it is minus of 6, divided by what? Divided by the R, that is the radius. The radius, what do we have? The radius we have 6 centimeter. But if you look at it down here, we have 3 times 10 to the power of minus 2 square. And okay, let's take us back again, because we have to expand how we get this value. You can even ask yourself, how do we get this value? So how we get this value is that, so I hope you have in your own calculator now, because I told you the value that we are given here, it is in centimeter. So you see that we have to convert it to meter. So how do you convert it to meter? Then if you are to convert it to meter, we'll just divide this value, the 6 divided by 100. If you divide 6 divided by 100, you will end up having a value of 0.06 m. That is the value that you will be given if you press your own calculator. That if you press the 6 divided by 100, you will end up with 0.06 m. That is because it is in centimeter. We have to convert it into meter for us to do our calculation. So after that, but if you look at it here in our question here, because this question, it says that it is placed under 3 corners. 3 corners also, it is in square. So if you look at it, the field or the force at O due to charge at, if you look at it, the A and the C are mutually cancel each other. They will cancel each other and off us. So if you look at it, you are considering the charges, because they say the charges, they are 3 positive micro coulomb. So we are just considering the point A, D, and B. So you see we are just considering those side, or let's say those side. So if you are considering those side, then we are, and that value of that O. So you see that is the center of the field. So and we are talking about the diagonal of it. So you see that is where we come to find the value of this 6. So if you can remember, I told you we have to make this value of 6 into centimeter to meter, and we do the fraction of our value. We have a value of 0.06, that is in meter. So, and if you are to find the diagonal of it, then we are also to divide it and into two equal parts. And if you divide it into 2 equal parts, then we'll also press our own calculator. If you press your own calculator right now, and if you press your 0.06, divided with 2, that is you divided with it 2, diagonal of it. Then if you press the 0.06 divided by 2, you will end up having a value of a value of uh, a value of 0.03. That is the value that you will get. You will have a value of 0.03. So that value is the value of the radius of the lung. That is the r. That is the value of that r. I told you you have to use your own calculator and press it, and the value you have to check if it is in centimeter or if it is in meter. So the value here given to us, it is in centimeter. So if you can recall just now I told you our value that we have, it is in meter, which where we have a value of 0.03. That is our value of r, and our value of r, it is in square. So and that is in square. That is where we have this 3 times 10 to the power of minus 3. So you see, that is how we get this value of 3 times 10 to the power of minus 2 open bracket square. That's so this is how we get it, and that is why we have that value. You just press your own calculator, you do the division of that centimeter, 0.06 divided by 2, you will end up having a value of 3 times 10 to the power of minus 6. That is how we get the value of the radius. So and this value of the radius, it is also in square. That means that you also have to press your own calculator again and press the value of the radius. That is the 3 times 10 to the power of minus 2 in square. If you press the 3 times 10 to the power of minus 2 square also times 3 times 10 to the power of minus 2 square, you will end up having a value of 9 times 10 to the power of minus 4. So that is the value that you have for the radius. So if you have that value of the radius, then you will just do the multiplication. And if you just if you do the multiplication and press you press the constant value of the proportionality, the k for the column, times the charge given to you divided by the radius that you have, you will end up having of this value. Okay, and if you press your own calculator and press the 9 times 10 to the power of 9 times 3 times 10 to the power of minus 6 divided by the radius, that is the 9, not this, but the square of this value, the square of 3 times 10 to the power of minus 3. That is the value that we have, the 9 times 10 to the power of minus 4. You divide with the 9 times 10 to the power of minus 4, then you will be having a value of 3 times 10 to the power of 7 per column. So you see, if you just do the multiplication of this thing, you will be able to find the field intensity, the electric field intensity of those 3 charges, not 2, of those 3 positive, also those positive 3 charges. So this is the electric intensity of those 3 charges. Also the point of intersection of diagonals. So this is how we calculate the electric field intensity of those 2 charges due to that diagonal intersection of them. So and also the value of the unit for the SI unit, because impedance unit is very important. The unit that we have is Newton per Coulomb. So this is the value for electric. This is the SI unit for electric field intensity. So here we are going to talk about the electric potential. So normally potential, when we say potential, we have to go back to, let us talk about, let us recall what do we mean by potential energy before we even go to electric potential. So when we say potential energy, normally we are talking about the energy stored in an object, or the energy of that object that it have inside it. That is potential energy. So the energy that is stored in inside that object or that particle. So here we are talking about the electric potential. So electric potential is the amount of work needed to move a unit charge from a reference point to a specific point against an electric field. So you see, it is amount of work needed to move a particle. So this is talking about the amount of work that you need to move a particle from a reference point, that is from the reference point, that is the main point, to a specific point against an electric field. So you see, and normally that reference point is talking about the earth. So if you look at this diagram here, it's trying to show us or trying to tell us the electric field. That is the charges here. That is, let's say, the positive charge to the negative charge. If you look at it here, the like the lines in the green, they are the charges. They are the q the charges, and the lines of going up there, that is the electric, the electric energy. That is the energy going up there. So but you are going against the electric field, because the electric field, the E, if you look at it here, the E, it is going upward, but the amount of work that you needed to bring or to move that unit charge from a reference point to a specific point. So you see, and normally that reference point is the earth, the amount of work that you need to move that charge. So you see, you are going against the electric field. So the amount of work that you need is talking about the electric field, the amount of work needed to move a unit charge from a reference point to a specific point against an electric field. That is the amount of work that you need for you to move that unit charge from that reference point. So this is what electric field is talking about. So, and also electric field at any point around a point charge is given by, so this formula is for electric field, but only around any charge, any point charge is given by V is equal to K times or multiplication of Q divided by R. So normally V normally stands for the electric field. That is that is the symbol for the electric field, and is equal to K. And why normally this K is the Coulomb's law, just like we have mentioned, and it is a constant of proportionality that has a value of 9 times 10 to the power of 9 Newton. And also this the Q, the Q that we have is the point charge. That is the point of the charge that we have. And also the R or the D, or the R is the distance between any point around the charge to that point, to that charge point, to that point charge. So you see, it is the distance from any of the point, around to that point charge, to the charge point. So it is the R. So normally this formula is used for calculating electric potential around a charge, that is the Q. And also that says V is equal to K times Q divided by R. So the Q and the R, they can be given, but the R normally it is in constant. So this is about electric potential. So let's solve an example of the one is talking about the electric potential. The example is talking about to find the electric potential at a distance of 2 centimeter from a proton, and the Q is a positive E, that is a positive, and that have a value of 1.6 times 10 to the power of minus 19 C, that is in Coulomb. So if you look at the value given here, if you look at it, you will see that the radius that you have, it is 2 centimeter. And if I can recall, I told you that if we have a value in centimeter, we have to convert it into meter. So you see, we have to do the conversion of this value, and normally it's simple, we just divide it with 100. So the question says we have to find the electric potential, and normally we just finish the explanation for the formula for finding calculating electric potential. So normally it says that this B, normally the V stand for the electric potential, that says is equal to K Q all over R, and the K is a constant of proportionality. And also if you can look at our question, normally the K is not given. Why? Because it is a constant of proportionality. it is already constant. The value of that is not changing, but the Q and the R, they can be changed, or they can be given. So if we just put our values, and we can be able to calculate the electric potential with electric potential. So that's it. And if you press our own value, we just put the value of the key. That is 8.99 times 10 to the power of 9. That is the value of the key. Multiplication or times the q. That is the q. It is in the q of the proton. That is 1.6 times 10 to the power of minus 19, divided by the radius. But the radius is 2 centimeters. That means that we have to turn it into meter. Then we just divide it by 2 divided by 100. That is why we end up with 0.02. So this is how we do the conversion. So, and if we just press our own calculator and press the value of the k multiplication, with the value of the q divided with the value of the radius, then we will be able to find the value of the potential, of the electric potential. Where if we press the value of 8.99 times 10 to the power of 9 times 1.6 times 10 to the power of minus 19 divided with 0.2, then you will be having a value of 7.2 times 10 to the power of 8 V. That is the value of the electric potential that we have. That is the value of electric potential at a distance of 2 centimeter from a proton, and it has a charge of 1.6 times 10 to the power of minus 19 Coulomb. So I think this is the end of the 6-week physics class to the SS3 student. So I wish you good luck.